Hey, hi, good morning, everyone. Let's start. Let's share my screen.
Good morning.
Morning. Morning.
Good morning. Okay. Yeah, I think last time we were discussing standard deviation, right? And I think it's all started from this measure of dispersion. So we started that, okay, if we will take example of these three series, right? Series 1, series 2, and series 3, we can see that just using mean and median, right? It is impossible to differentiate between these three series, right? If I will not look at the data, just based on mean and median, it will look like as if all three are exactly the same. So if you want to measure the spread of the data, right? So I will be needing something else apart from mean, median, and mode. So we thought maybe range will be a better option, right? Because if I want to differentiate between these three, the range can give me um, like a good idea that one is having more range as compared to second, and second is having more range as compared to three, right? But then we saw a few other examples like this, where the range was exactly the same, right? But the data was very different from each other. Then we thought that, okay, it will be better to kind of use something else which can, differentiate between all these different kind of, series. The first one, for example, what we decided was that we will try to measure the distance of each point from the mean. Like, for example, what is the distance of this point with the mean? What is the distance of this point from the mean? What is the distance of this point from the mean? What is the distance of this point from the mean? And what is the distance of this point from the mean? That's what, for example, we want. Then we calculated each distances, and then we just took an average of all the distances, and that distance, that total average distance came out to be 0. Okay. Why so? Because uh, this distance 1 is negative, distance 2 is negative, but distance 4 and distance 5 was like positive. So if you add everything together, it will become 0. Okay. Now, if we want to overcome this problem, we have two ways to do it. One is using the mode. Let's say you can took the absolute values. Or the second thing is what we can do is we can take a square of it. Okay. And in statistics, always and always, we need to remember one thing, that whenever we want to remove the sign of something, it's always better to take a square. Like in stats, you can take it as a rule that whenever I want to remove the signs, right? Not even in this, you will see later also that whenever I will have a problem where I need to remove the sign, they will always square it and then we'll take under root. Okay. So we will square everything, we'll take under root of that. Um, and whatever that value came, right, is something which call it as standard deviation. Okay. The formula of standard deviation is, the generic formula is xi minus mu square divided by n. What is xi? Xi is the point. What is mu? Mu is the mean. N is nothing but the number of values. Just 1 minute. Okay, so I'll just write it here. What are xi? Xi are the points, individual points. What is mu? Mu is nothing but your mean. And what is n? N is nothing but number of points. Number of points. Okay. Right. And what is variance? Variance is nothing but the square of standard deviation, which is nothing than the under root will just go away. That's it. Okay. And what we need to remember is we need to remember the definition of standard deviation as well. And that's how maybe you can remember the formula, or the other way around. remember the formula, and that's how you will remember the definition, right? That what is standard deviation? Standard deviation is a measure of distribution of data around the mean. Why I'm telling you is that the definition is important because later on, like when we will start like solving a few numeric question, it will be given to you that let's say maybe mu is 36, standard deviation is 28, calculate XYZ, right? So those things should not be just numbers to you. Like it shouldn't be like for example, when the people say mean 36, in back of your mind, you already know that okay, the average is 36. It means that on an average, all the points are distributed around 36, like more or less, right? Similarly, if someone is saying sigma equal to 28, then it should come to your mind. It means that, okay, on an average, every point is at a 28 units distance from the mean. Okay. Then what we did was we saw that different distribution corresponding to different standard deviations. Um, this standard deviation, for example, this is the one which I have marked in yellow. This distribution belongs to standard deviation equal to 5. The one which I have marked in green, standard deviation equal to 10, and this one is standard deviation equal to 20. Okay, so it means that more the standard deviation is, more distributed the data will be around the mean. Okay, what is the mean in all the three cases? Mean is 100. Okay, mean is 100 in all the three cases.
Uh, s- So if the mean is 100 and standard deviation is 28, means
Hmm.
like so it is distributed like maybe it will go till 128, we're saying, like the range.
Sorry, you said mean is 100 and standard deviation is 20. This is what you said,
28.
right?
Yeah, 28. So so how will the data, like the data spread will be like, say, if I imagine the data spread will be like 128, like max, or
No, it's not like that. Okay. We are just saying that on an average, let's say if I, for example, if I'll tell you that on an average, the Indian person earns 10,000 per month, right? Can you say that the range will only be between 0 and 20,000 or 0 to 30,000 or 0 to 40,000?
okay.
Nice, right?
Hmm.
So it is just telling you on an average, each point is at a distance of 20 on an average,
Okay.
right? So it means that there can be a few points which can be, let's say, 1,000 as well, right? There
Okay.
can be a few points which can be, let's say, minus 20 as well, minus 30 as well. But on an average, the points are at a distance of 20. Okay. But that doesn't restrict our individual point from taking any value.
And,
Okay. Individually, any point can take any value, but collectively, they will be at a distance of average distance of 20.
and what variance do, like, is how variance is predicted here? I got this one.
So variance you need not to worry about. It's just that I don't know. Like to be very frank, like what is the use of variance? At a lot of places the variance is given, but in general we convert it to standard deviation and then use it.
Okay.
Okay. So I'm not sure how it is used. Like I have never used variance in any of my numericals or anywhere.
Okay. Nice.
Okay. Um, right. And then the other thing that we discussed was that this is a symmetric distribution. We call it bell-shaped curve. We call it bell-shaped curve. Okay. Why bell-shaped again? Like because a bell is like this, right? More or less. Because a bell is like this, right? So they call it a bell-shaped curve, right? Or in general, we call it a normal distribution. Okay? It's a bell-shaped curve, and the more technical term will be a normal distribution. Okay? A normal distribution is symmetric around its mean, and it is bell-shaped. Okay? Now, what is the benefit of like from this point? I want to jump on to the next topic, which is like normal distributions. And we will try to understand why normal distributions are important, right? what is so special about normal distributions, right? It is a simple bell-shaped curve, but the best part about normal distribution is that most of the distributions in our real world, right? Most of the distribution in our real world are close to normal distribution. So it means that if I will collect the data of height of all the human beings, you will see that it will follow a normal distribution. Okay. Similarly, if I will take the weight of all the all the human beings, you will see that it follows a normal distribution. Right? Anything that you can think of in general will follow a normal distribution if it is naturally occurring. Okay, and there are certain rules that a normal distribution follows. Let's see what are those rules. So a normal distribution is follows something called empirical rule. All the normal distributions will follow a empirical rule. What is this empirical rule? Empirical rule means that, okay, first of all, like this is a normal distribution, right? This is a normal distribution. In this curve, when we are saying normal distribution, we are talking about this curve. Okay, rest other things are just something that you can ignore for now. This is a normal distribution. It's a bell-shaped curve and it is symmetric around the mean. This is the mean. So if you look at it, this distribution is symmetric around the mean. Right? It's exactly the same, a mirror image. So it is a bell-shaped curve. It is symmetric around the mean. So it is a normal distribution. Now, what are the properties of normal distribution? The first property of normal distribution is that the 68% of the data, the 68% of the data of any normal distribution, okay, will be present in plus minus one standard deviation. Okay, so it means that this area that I see from here, this area that we have, this area makes 68% of all the points, right? And in all the normal distribution, this will happen. In all the normal distribution, this will happen, that this will have 68% of the data. Okay, plus minus one standard deviation. Similarly, plus minus two standard deviation, plus minus two standard deviation will have 95% data. Okay, plus minus two standard deviation will have 95% data. It means that if I will include this green area and the yellow area together, okay, not just the green area, is the green area and the yellow area together. Okay, if I will include this yellow and green area together, then it will be 95% of my data points. And similarly, if I will look at plus minus three standard deviation, plus minus three standard deviation, that will cover my 99.7% of the data. Right? 99.7% of the data. It means that, like, let's try to understand it using an example. Now, the mean is 1150. Okay, this is the mean. Plus one standard deviation is 1300. So here the standard deviation is how much? What is the standard deviation? If mean is 1150, mean plus one standard deviation is 1300. What is the standard deviation? Right? Very nice, Stevie. 150, right?
150, yeah.
It will be 150. So mean plus two standard deviation. Two standard deviation. So it means that 1150 plus 300, right? So it is 1450. Mean plus 3 standard deviation is 1150 plus 450, that is 1600. Similarly, mean minus 1 standard deviation is 1000. Mean minus 2 standard deviation, right, is 850. Mean minus 3 standard deviation is 700. Now, if I will ask you what is the minimum and maximum value in this distribution, what is the minimum and maximum value which is possible?
700 is like minimum and 1600 is like maximum.
Right and wrong. Okay. So what I mean by that is this is like this 700 and 1600 just cover 99.7% of the values. It does not cover 100% of the values. Okay. So the range from for 100% of, like if someone will ask me, what is the range of 100% of the values? Right? Let's say we are saying that from 1000 to 1300, I have 68% of data, right? If I'll increase the range 850 to 1450, I said, okay, 850 to 1450, I have 95% of the values, right? 95% of data points fall between this and this. And if I will increase the range from 700 to 1600, that will cover 99.7% of the values. But if someone will ask you, okay, then what if I want to cover 100% of the values? What should be the range here? Then theoretically, it is from minus infinity to infinity. Okay? Minus infinity. It means that in this distribution, we are not restricting any individual value. An individual value can be as small as minus infinity and as big as plus infinity. There is no constraint on that. So we cannot comment on minimum and maximum value of a normal distribution. Theoretically, a normal distribution, an individual value can be anything, right? But 99.7% of the values will fall under plus minus 3 sigma.
Like, but when we have the data set, won't we
Uh,
know like the minimum and the maximum value then?
right,
How?
right. We will know. You are right, right? But I'm just saying, let's say if you just have the distribution, if someone will tell you, like if I will tell you that human beings, right, on an average have a height of 168 plus minus, let's say 30 centimeters standard deviation. If I'll just tell you this, and then I will ask you theoretically what is the range of human height, then theoretically it can be from minus infinity to plus infinity. Okay. If you have the whole data, then obviously you will know like what is the range. But if you have just the average and the standard deviation, then the values can vary from anywhere to anywhere. Okay. This means mu plus minus 2 standard deviation, and this is mu plus minus 3 standard deviation. This is the formula of standard deviation. Okay, this is the formula of, call it sigma, is the formula of standard deviation. Okay, before I move any forward, right? So whenever you want to understand any distribution, right? Like for example, I want to understand this chart. The very important part is to understand first what is the meaning of x-axis and y-axis, right? Let's say, for example, here the x-axis is maybe the marks obtained. These are the, like some exam I have conducted in which you get marks out of, let's say, 2000. So this is the marks obtained. The main thing is what is my y-axis here? In a normal distribution, what is the y-axis? To create any chart, you need x-axis and y-axis both, right? So let's say if x-axis is marks obtained, what is y-axis? number of occurrence, right? And in this case, it is a percentage of occurrence, right? So percentage of points, number of points, in both way you can draw a normal distribution. So this is percentage of students. Okay, percentage of students. So it means that if I have conducted a exam, then around 68% of the students have scored marks between 1000 and 1300. Around 95% students have scored marks between 850 to 1450. Around 99.7% students have scored marks between 700 to 1600. Okay. Any questions so far?
What is standard deviation, sir?
Standard deviation is nothing on an average how much far you are from the mean. On an average, how much far the points are distributed from the mean.
Oh, thank you.
Like when we are applying standard deviation, we are going to apply it on data set, right?
We are
So
going to apply for?
we are going to apply it on in a data set, for
Okay.
example,
Okay.
like for the distribution, to know the distribution. So in that scenario, also like we will get 99.7%. Wanted to know like from the data set, like the whole data, it will analyze the whole thing. Why
Right,
it's
right,
like
right.
going
Right, right. Yeah, I understood your question. The thing is that most of the time in the world, we don't know the data. Okay. Let's say if whatever I'm trying to measure, let's say turtles, right? I want to like see the distribution of weight for all the turtles in the world, right? Will you be able to capture all the turtles and take their weight measurement and then let's say release them? That is not possible, right? And above all, like it is not even needed. So what the scientists do in general is they will take a sample of the all the turtles. They will take a sample of it, and from that sample they will know the mean, they will know the standard deviation, and then they can extrapolate it for the population. Okay, so the assumption, let's say for example, your doubt was based on an assumption that I will always have the data, the whole data, which is not true. In general, most of the time you have a sample of data.
So this is like a approx value for our data and
Right, exactly.
approx value
Exactly, you are
and
right. Right, because what happens is that like for example, I know that the weight of turtles will definitely follow a normal distribution. Okay, if like for
when we have
example,
like
mhm,
sorry like when we have like large data set, then in that case we really like comes in handy.
right,
Where-
exactly, right, right.
So
So
it used to
mhm,
like for knowing the pattern, like where's the most of the like data set the data thing is happening, like between 68%. We need this information,
right,
95%.
right, and I'll show you later also like how it will be used. Right, I understand your doubt as of
Okay.
now that you are like a little confused about how it will be applied. Right, but I will come to
Mhm.
that. Normal distribution has a
Okay.
lot of application because in a real the normal distribution follows a certain rules. Right, let's say for example this empirical rule. Right, the 68, 95, 99.7 is called empirical rule. Okay, so a normal distribution follows a rule, and this rule have an extensive application in case of stats. We will see that how this rule will be converted into probabilities later. Okay.
Sir,
Uh,
one doubt. Sir,
mhm.
one doubt. This 68%, 95%, 99% are fixed numbers?
Yes,
Or are
these are fixed numbers.
okay, okay, for
That's the
empirical one.
no, for a normal distribution.
Okay.
Normal distribution, this 68%, 95%, 99.7% are fixed number. Because these numbers are fixed, the people have given it a name. Right, that
Okay.
by empirical rule we know that, like maybe most probably the guy who discovered it, I'm just making it up, I don't know, but let's say the guy who made it up, his name was, let's say, empirical maybe, right? So we have a rule based on his name, and he, like for example, discovered it that a normal distribution always and always will follow a rule that plus minus one standard deviation, the 68% data will be covered, plus minus 2 standard deviation, 95% data will be covered. Similarly, plus minus 3 standard deviation, 99.7% data will be covered always.
Okay, so this rule is called empirical rule.
Right, exactly.
Okay.
Okay, so this number is fixed. And based on this, the people do a lot of calculations, a lot of assumptions are made just based on this rule.
How
But
do we come
can
to
this
know
correct?
that? How do we come to
No,
know
no,
that
go for it.
68% area, like M minus 15D and M plus 15D points you have taken it? So
Right.
are there Q1 and Q3, something like that, or how are the points?
How are these like plus minus 1 standard deviation points are plotted? Is what you're asking?
Okay, I mean, how to get that 68% area points? That's what is my question. Any points that we have to consider, like how much distance are you going from the mean to both the?
Plus minus 1 standard deviation.
Okay, okay.
If you will go plus
Same in
minus
standard
1,
deviation. Okay, okay, fine.
if you will go plus minus 1 standard, it will be 68%.
Okay, okay, thank you.
So
Sir,
how
can
can we
you
know that,
explain
okay,
like
when we should use this normal distribution?
Actually, in real life, we always assume all the distribution to be approximately linear.
Okay. I mean, whenever we are giving any problem set or a data set,
Right, right.
like how do we?
Most of the time you can assume it to be a normal distribution. This is what we do. We always assume it to be a normal distribution, then we solve it. And most of the time that assumption will be correct. Let's say, for example, if someone is taking a measurement of a sugar level in human beings, okay? Let's say we say that 100 is a fine range. Above, let's say hypothetically 100, above 100 you are diabetic. Let's say below 100 you will not be diabetic. But if you look at the distribution of glucose level in human blood, it will definitely follow a normal distribution. Similarly, if you talk about the blood pressure in human being, it will not be one single value. It will not be like 80 and 120 are like fixed values. If you will see, it will follow a normal distribution, right? So anything natural occurring always follow a normal distribution. Always.
okay, so like according to this, like for example, if the mean of the exam score number is like 80 and the standard deviation is 5. So does it mean like the most of the student have the marks from between 75 to like 80 plus 5, 85?
Right, right. 68% of the people will have marks from 75 to 85.
Okay. Oh,
Okay. So in nature, it will all like for example, if I talk about there are so many suns in the or we should call it stars, right? There are so many stars in the universe, right? And each star has a lot of planets associated with it, right? Now I cannot go and count all the stars and then all the planets associated with them. But let's say if I'll take a sample of stars, right? And create a data set that, okay, how many planets they have associated with them, that will also follow normal distribution, I'm pretty sure. There will be an average number, which most of the stars will have. Let's say, for example, most of the stars have 10 planets associated with them, right? And then there will be a standard deviation, and that will follow a normal distribution. Okay, because it is natural occurring. Natural occurring things most of the times follow a normal distribution.
Yeah, one more question. So this mean, right? Mean plus 1 SD, mean plus 2 SD. So here 192, what's the value for here? So
Sorry, plus 2 SD, plus 3
yeah,
SD.
yeah.
Yes. What was the next thing you said?
Mean is 1150.
Right.
And after plus 1 SDM, mean plus 1 SD. Here 1300.
Right.
Here 1 SD, how what's the value?
So so your mean is actually should be represented with the number mu. Mu is your 1150. That is your mean.
Yeah.
Your standard deviation is 150, right? So mu plus sigma, that is plus one standard deviation will be what? 1150 plus 150, right? That is 1300.
Okay, how to get to know this 150? How you get?
Let's assume for now that these two numbers are given to you. Let's just assume that these
Oh,
two things are given to you.
okay, okay.
Okay.
So these are fixed.
These are not fixed numbers, but here I have given it to you.
Okay, okay.
Obviously, each distribution will have a different number. Like human height will not have a mean of 1150. It will have something else. Let's say 165 centimeters. Some
Okay.
different standard deviation, right? But if you know the mean and the standard deviation, this is the graph that you can create yourself.
Okay. Got it. Thank you.
Okay. Now let's do one question. Let me ask you a simple question. What percentage of data points, okay, what percentage of data points are in this shaded area?
34.
34.
Before
34%, right? Easy. So this data set has 34%. This shaded region has 34% because it is again this yellow region plus this this region, the one which are marked in red. Together they make 68% of the data. So the half of it will be 34% because these are two identical halves. What percentage of data points are present in this shaded area?
23.5.
14%.
14%.
23.5.
23.5 looks correct to me. Right? What
95
percent?
divided by 4, right?
95 divided by 4. No.
95 divided by 2 minus 34.
Very nice. Right. So, or what we can do is like what you said is correct. So, what I can do is I can say simply 95 minus 68 divided by 2. Right? Is it correct or not?
Yeah, correct.
That looks to be correct.
Okay. So, it will be how much? It will be 270, 80, 90. I think 17 divided by 2. Am I right?
It's 13.5.
13.5%.
Okay, it's 27. Yeah, so it is 27 divided by 2, which is nothing but 13.5%. So this shaded region is 13.5%. Is it clear to everyone like why it is 13.5?
Yeah.
yes.
Okay. Now, if I will ask you, what is this shaded region?
One 1.3,
Okay.
99.7 minus 95 by
4.7.
4.7 divided by 2, right?
2.5.
Yes.
So it will be
2.35.
2.35, okay. Minus 95 divided by 2. So you are saying 2.35, okay. 2.35%. This much data is 2.35%. Clear to everyone? Again, if it is not clear, let me know, I will explain.
Yeah, can you explain? Like, I'm not getting how you're calculating.
Okay, sure. So this whole region that we have from here to here, right? This whole region that we have, end to end it is how much? Here to here, how much it is?
99.7.
99.7, right? So this region, this whole thing is 99.7. Okay. Now what I'm doing is I'm removing this area from it first. Okay. I'm removing this much area from it. So how much I have removed? What is this green region?
95.
95%.
Right? 95%. Right? Now these two regions are left. One region this and the other region is this. Let's call it A and let's call it B. So now I know that A plus B is how much? 99.7 minus 95. Right?
Yes.
And A and B are identical. So I can just simply say 2A is equal to 99.7 minus 95. Right? So A is how much? 99.7 minus 95, that is 4.7 divided by 2, which the people said is 2.35%. Okay, correct?
Yeah, got it.
Okay. Now let me ask you another question. We will see application of all of these, guys. Okay, so it may not be immediately, but like 2-3 classes down the line, the concept that we are learning right now, we will see the application of that. Now let me ask you a question. Let's say this point is 850, right? I want you to tell me what percentage of data points are less than 850. What percentage of data points are less than 850? Is it
2.5.
your 2.35?
2.5.
What it is?
2.5.
Yeah, 2
Because we have to take 100%.
Very nice, right? So when we are talking about less than 850, I'm not talking about 700 to 850. This 2.35% was what? 700 to 850, right? This point. But that doesn't mean that there is nothing beyond 700. Okay? This 99.7% just covers plus minus 3 standard deviation. But there is data beyond this as well. Okay. So when I'm saying less than 850, it means that less than 850 is the same as 100% minus this red area, right? This red area. This red area. And how much is this red area? If someone will ask me how much is this red area, I'll just simply calculate it like this. Right? I know that this yellow region, by yellow region mean like till end, like as like this. This yellow region is how much?
50%.
50% of my data, right? The normal distribution is identical around the mean. So it means that 50% data is here. On this side. On this side of mean, there's a 50% data. On this side of mean, there's 50% data. Right? So this yellow region is 50%. How much is this green region? How much is this
30.
green region?
34.
34%. Nice, right? And how much is this shaded region?
13.
13.5, right? Something, how much? Yeah, 13.5. So we are saying this is 13.5. So if on this side of 850, I have, if on this side of 850, I have 50 plus 34 plus 13.5, how much it is? 84. 84. 97.5,
97.
right? 97.5% of the data. So on this side of 850, how much data will be there? It will be 100 minus 97.5, which is 2.5.
2.5.
Okay, so this is the answer. 2.5% data is present. Okay, so on this side, 2.5% data is present. Okay, now let me ask you another question. Like everything is clear so far or not?
Yes.
Okay, nice. Okay, and now let me ask you a few other questions. So there is a concept of Z value. Okay, Z value or Z value. Okay, one and the same thing. Some people call it Z value, some people call it Z value. Okay, but it is more or less the same thing. What is Z value? Z value is nothing but how many standard deviations away a point is from the mean. Okay, what is Z value? If someone gives you a Z value of 3, the meaning of that is that that point is 3 standard deviations away from the mean. So Z value tells me how many standard deviations away, how many standard deviation away a point is from mean. That is the average. How many standard deviation away a point is from the mean. Now, if I will ask you, what is the Z value of 1300? What is Z value of 1300?
One standard deviation away.
Standard deviation.
One standard deviation. Very nice. Right? Or one, because here the like we need not to say standard deviation because that is by default. That is the definition of Z value. If I say 1, it means that 1300 is one standard deviation away from the mean. Now, if someone asks me, okay, what is the Z value of 850? Then
Minus
2.
2.
2, very
minus
nice. Minus 2 actually. Yeah, sorry, that's correct. It is minus 2. So 850 is at minus 2 standard deviation away from the mean. Okay. Similarly, if someone will ask me what is the Z value of 1000, then it is what?
minus
-1.
Minus.
Minus 1, right? Because it is minus 1 standard deviations away from the mean. And what can be the theoretical range of Z value?
minus 3 to 3, I guess.
If the theoretical range is
Minus infinity to infinity.
minus infinity to infinity. Okay. Because the points can be obviously greater than 1600 also. The points can be less than 700 also in this case. Right? So theoretically, the range of Z value is theoretically of Z value is from minus infinity to infinity, theoretically. But most of the time, as you can also see, it will vary from minus 3 to 3. Okay. So I'll write two ways then. Practically, it will be from minus 3 to 3. The range of Z value is from minus 3 to 3, practically. Theoretically, minus infinity to infinity. Okay. Now, let me ask another question.
Hello, I have a question. Like here, the mean is 1150.
Yes, right. The mean is 1150.
Okay.
Um, Right?
Hi, Puneet.
So,
Consider if a value comes between like 1300 to in between like 1350.
mhm.
So that means it should be means what should we have to take like Z value?
Yeah, I was discussing that point only. The
Okay.
next point was, what is the Z value of let's say 1400?
One 1.5, more than that.
See, the question is very simple. How many standard deviation away 1400 is from the mean? So you need to measure the distance of 1400 from 1150 in terms of standard deviation, right? So what I will do is, there's a formula for Z value. The formula for Z value is xi minus mu divided by sigma. See, this will give me how many standard deviation away a point is from the mean. So xi is what? 1400 here in this case, minus mu, what is 1150, divided by sigma, that is 150. So 1400 minus 1150, it will be, I believe, 250, divided by 150, it will be 5 by 3, it will be 1.67 approximately. Okay, so this formula is a very important formula. In again stats, it is a very important formula. Okay, so we need to remember this for sure. Z value is nothing but xi minus mu divided by sigma. Again, I will repeat the same thing. Either remember the formula using the definition or remember the definition using the formula. Okay. What is the definition of Z value? The Z value tells me how many standard deviation away a point is from the mean. So whenever someone says Z value of 2.6, Z value of 1.9, Z value of -3, Z value of -7, whenever someone says Z value of this much, it should not be a number to you. Don't just start solving question just assuming it, okay, the value of Z is this much. In the back of your mind, it should immediately tell you that, okay, Z value minus 2.6 means that my point is at minus 2.6 standard deviation away from the mean. Okay, this is how much clear we should be with the definition. Okay, the one that I'm star marking is something that you need to remember.
Can you explain how the standard deviation works in practically?
We'll come to a practical application a little later, right? As of now, we are just trying to learn the math, and then we'll see like how that math will get applied later. Okay.
Here we took like sigma 150. So 150 is like point, the range between the points, right? From like 1500 to 1300 is 150. But from 1150 to 1450, no, from 1300 to 1450 is 100. It's not 150.
From 1300 to 1450
1300
is
100.
100. How come it is 100, bro?
150 plus 100, 250.
No, from 1300 to 1450, you are saying the distance is 100.
Yeah,
This
from
this
but 1150 to
this is not 100, no. 1300 plus
I'm like,
100 will be 1400, right? This is
no,
150.
not that.
Uh-huh.
That below it, like M plus one. What is that? M.
This one. See, this
It's
is M.
D.
This is
One
M.
SPP.
This is M, right? This is M plus one standard deviation, SD.
It was
Okay.
looking so small. I don't
Yeah,
know.
no problem, no problem. Right? SD. Similarly, mean plus two standard deviations. So this is your mean. From this mean, you are going to two standard deviations. That is mean plus 300. Right? That is 1450.
Yeah, that is.
Okay.
Yeah, it got me confused. I don't know.
No,
Like
no, I thought you were saying from 1300 to 1450, it is just 100 points.
Yeah, I thought I understood everything, but then I saw that and it was just
No problem here, no problem. Okay. So any other question, anyone?
Sir, can you explain like what is standard deviation?
What is standard deviation?
Mm.
Standard deviation is something that we derive, let's say, for example, here. This thing, you remember this this example that we took?
Actually, I joined little late to the class.
No, this is from the last class actually. So standard deviation is nothing but how much far, on an average, how much far away a point is, the points are from the mean. Okay. So for example, here my average was 14. So this is 12, this is 13, 14, 15, 16. 5 points are there. What is the average of that those 5 points? 14. Okay. So the distance of each point from the mean will be d1 is nothing but 12 minus 14, right? This is 12, this is 14. Because why I'm taking 14? Because 14 is the mean. If you will take 12 plus 13 plus 14 plus 15 plus 16 divided by 5, it will come 14. So xi minus mu is minus 2, 13 minus 14 minus 1, 14 minus 14. So what is this? What is this yellow thing 14, 14? Is the mean. So I have taken the difference of each point from the mean. I have taken the difference of each point from the mean, took a square of it, then took an average of it, and then put a under root of it. Okay, that will give me the standard deviation. That is the formula of standard deviation. Approximately, you can just say how much far points are on an average from the mean is something we call it standard deviation. Okay,
Okay.
okay. Any other question, anyone?
So if we have an outlier, it will affect the standard deviation also, right?
Yes, yes, it will. Okay, but in a normal distribution, most of the time we assume that if there will be an outlier here, to neutralize it, there will be an outlier here as well. Okay, because normal distributions are symmetric around the mean. Uh,
So
yeah,
what is
tell
the
me.
significance of calculating this Z value, Puneet? Like,
Mhm,
because we are defining that from mean, let's say 1 SD, 2 SD, and from on the negative side also.
mhm,
So we calculated this uh, Z value and came to be 1.67. So
mhm.
is this something that we can say that from mean 1.67, if we take on the positive side and on the negative side, that will cover
Mm.
68% of the data?
No, 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 nothing like that. I'm coming to that. That is not correct. But
Okay.
I'm coming to that, right? What is the point of Z value, right? Why
Yeah,
we are calculating it? I'm
right.
coming to that. Like slowly and slowly, we'll
Sure,
try
sure.
to go there. Okay. So we calculated the Z value of 1400 came out to be 1.67. Okay. Now let's do a different question. Okay. What is a different question? I want you to calculate. Okay, actually, not this. I want you to calculate, let's say, I'm assuming somewhere here will be 900. Somewhere here will be 900. I want you to calculate what percentage of data points will be less than 900. Okay. That is this shaded region. Okay. I will be back in a minute. Meanwhile, you guys calculate this. You guys calculated?
It is around like 4 to 5%.
4 to 5%, no fixed value like last time. 4.16%.
4.75.
How did you
4.75.
guys calculated this? 4.16.
I got 4.75. I
Okay.
I took
I
like
have
that,
taken
then I applied like imperial rule to it. So I
Mm-hmm.
got that box 4.75.
So have you assumed that, let me ask you this. Have you assumed that this
7%.
much data, this much, and 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 this much is same? Have you assumed
No,
that?
that divided in three
No,
parts.
I,
If you have to take 1000 between 850 divided by 3.
Divided by 3.
uh,
Okay. Mm-hmm.
So the blue shaded portion.
actually I have taken the Z value calculation
Mm-hmm.
and that way, like 900 1150 minus 900 divided by 150 that way,
Mm-hmm.
and it is getting like how much Z value, and 95% beyond that it is 5%, so
Mm-hmm.
it is 5%, so 2.5% plus the remaining 850 to 900 that way.
Okay. Mm-hmm.
Blue shaded portion percentage coming out to be 4.5, and
Mm-hmm.
the remaining 2.5 there. So the total becomes 7% below 900.
Okay. Cool. See, I think what you guys have done is like approximation rather than like the exact value to verify. You cannot divide it into three parts, equal three parts. For
Okay.
example, you cannot divide it into equal two parts also. Just for an argument's sake, right? Like just do this only. Oh shit. Uh, okay. Mhm. Just 1 minute. Hmm. So we were here. I said that we want to calculate, what is the data points which are less than this point. Okay, my simple question is, let's say if I'm exactly in the middle, hypothetically, if I'm exactly in the middle, will it divide these two into two equal half? Yes or no, according to you guys?
yeah.
So you are saying this data and this data will exactly be the same, given that these two distances are exactly the same. This is
No,
exactly
no,
in the half.
it
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 will
will
not
not be
be,
equal.
No.
Yeah.
right? Because this is a smaller area, definitely. This is a smaller area as compared to this because this has a bigger height. So assuming that it will divide it into two equal half, that will be incorrect. And I hope that also answers the question that it will not divide it into three half also. Three equal halves also. Is that correct?
Yeah, correct.
Right? So we can, like, to be very frank, this question was not solvable. Right? Me asking you what percentage of data, let's say, let me write this question first. What percentage of data points are less than 900? To be very frank, you cannot answer that question without some help. Okay, we will see what that help is. So if someone is asking me what percentage of data points are less than 900, you cannot solve that question. Okay, to solve that question, first I want you to calculate the Z value for this 900. Okay, can you do that? What is the Z value for this 900?
It's 1.33 something.
167
Sorry, how
minus
much?
1.7 minus
1.33.
1.33. Okay. So it is, let's say, for example, xi minus mu. See, always remember the formula and use it as it is. Xi minus mu divided by sigma. That is 150. So this will become 100, 250. So it is minus 250 divided by 150. Is it correct? Right? 5 by 3 minus 5 by 3. 1.67. Is that correct? Right? Minus 1.67. It's not 1.67. It is minus 1.67. Okay. The Z value is minus 1.67. Now we will see what is the benefit of Z table. Z value. The benefit of Z value is that we can use the Z table. And what is the benefit of Z table? We will see. Let's call it, let's simply search Z table. Okay. This website is there, www.ztable.com. So we'll go to this. And we will see how we can use this Z table. Okay, what is my value? Minus 1.67. So all I have to do is I have to find this, I need to find this value from the Z table. Minus 1.67. See, the values have started. This is till one decimal point. If you want to go to second decimal point, this is a second decimal point. Right? Let's say, for example, this is minus 3.2. This is minus 3.21, minus 3.22, minus 3.23, and so on. Right? Let's say, for example, this value is for 2.5, minus 2.5, minus 2.51, minus 2.52, and so on. Okay. So I will go till where? What is the value I need to find? Minus 1.67. So this is minus 1.6, minus 1.60, 61, 62, 63, 64, 65, 66, 67. What is this value? 0.0475. Let's write it down. The value is 0.0, right? Minus 1.67, 0.0475. Okay, if I will convert it to percentage, if I will it's called p value. If you will convert it to percentage, it will be 4.75%. What is this 4.75%? This 4.575% is nothing but percentage of data point which are less than 900. Okay, so 4.75% data is present. This data that we see, okay, till last, this data is nothing but 4.75%. Very straightforward. Okay, now let's do one more question just for practice. Okay, tell me what percentage of data points are present which are less than 800. I'm assuming, let's say 800 is somewhere here. What percentage of data points are present which are less than 800? Okay, simple thing. First calculate the Z value. Go to the Z table and see what is the value associated with that Z value. That will be your answer. Okay, 0.98. I'll just write it down on the side in case we will have a different answer. 0.99. Okay. So 0.99%. More or less same, I think 98, 99 then. Okay. Z value will be nothing but xi minus mu divided by sigma. Always make a habit of writing the formulas again and again. Okay. So that you'll not have to remember it separately. Whenever you are doing something, like just remember the formula. Just write down the formula again and again, and it will become easy for you to remember. 800 minus 1150 divided by 150. So it will be 200, 350 divided by 150. It will be 7 by 3 minus 7 by 3. So it will become minus 2 point, I believe 33. Yes. Okay. Minus 2.33. So I will go and I will check for minus 2.33. So this is minus 2.3, minus 2.31, minus 2.32, and minus 2.33. So 0.0099, right? 0.0099. So the p value, we call it p value, associated with it is 0.0099. So it means that the probability associated with it is 0.99%. What is the 0.99%? It means that 0.99% of data points are less than 800.
Can you show how you're taking the decimal values from Z table?
Yeah, right. So first we calculated the Z value. Is that part clear to you? Like minus 2.33,
Yes, yes.
right? Then all we have to do is like just check for minus 2.33 where it is. This is minus 2.3, right? And this is second decimal place. On top, we have second decimal place. So minus 2.3, 0. So minus 2.3, 1. Minus 2.3, 2. This is minus 2.33, right? So 0.0099.
Okay.
Okay, now let me ask you another question because this is an important concept. We'll do like a few questions on this. Tell me what percentage of values are less than 1200? Okay. Sorry, my bad. Very bad line. Okay, you got it, right? You can start solving it. What percentage of values are less than 1200? Will be a different table for positive Z values, just below the negative value table. Okay, just a heads up. So look, refer to the positive Z value table. And another thing, it can definitely not be less than 50%. this area will definitely be more than 50%, right? This yellow shaded region, this much itself is 50%. Okay, this much itself is the 50%. So the overall value will definitely be more than that, right? This is the additional green area apart from 50%. So the number will be definitely more than 50%. Right? Similarly, that number will definitely be less than 50 plus 34, that is 84%. Because even if I will include this area, which I need not to, obviously, even if I will include this area, then what percentage of values are less than this point? 50 plus 34, that is 84. So the percentage value will definitely be less than 84. Okay. So maybe 62 point something looks like the standard answer that I'm getting from most of you. The first thing that I will do is I'll calculate the Z score. Z value is, again, we will write the formula again and again. Xi minus mu divided by sigma. What is my Xi? 1200 minus mu, that is 1150, divided by sigma 150. It is 50 by 150. That is 1 by 3. That is 0.33. All I have to do is just look for p value associated with 0.33. I'll scroll down. I told like this, there's a different table for positive values. Just scroll down. Or maybe scroll up, I believe. Where is the table?
It's in down, but
Where is the table? Yeah, this one. Yeah, right. So 0.33. So 0.33 is this 0.6293. Okay, which is associated with probability value of 62.93%. Okay, if you got the same answer as 62.93, well and good. If you got a different answer, just please check once where, like, why it was different. Aman, actually, these are, experiment-based values, so small variation can be there. Okay, but yes, if you're getting, instead of 62, if you're getting 72 or 52, that much should not be correct. But if you're getting 62.93 versus, let's say, 62.83, that much variation is fine. Okay, but it cannot be drastically different. It cannot be 61, it cannot be 64. Okay, now my next question is, what percentage of values are greater than 1400? Not less than. Greater than 1400. This much area I want you to calculate. Very nice, Surya, right? We need to do 1 minus p here, right? Because the Z table will always give you values for the less than, always, for everything. It will give you the value of probability for less than. To get the probability for greater than, you always need to subtract 1. Okay, so Z table will always give you value for less than. If you want value for greater than, you need to subtract 1.
Right. Yeah.
Okay, so what we will do? We will first calculate the Z value. Z value means xi minus mu divided by sigma. What is xi? 1400 minus mu divided by sigma, that is 150. So it is 250 divided by 150. This is 5 by 3. Is 1.67. I think we have done it before, right? P value associated with the value 1.67 is how much? 9525.
15.
Sorry.
9515.
Okay, 9515, sorry. 1.6. No, that is for 1.66, right? 1.67, it is 9525. 9525. But that will give me the value for less than. I want the value for greater than. So what I will do is, I will do 1 minus p. That is 1 minus 0.9525. That will become 4.75%. Okay. Any question?
Puneet, I didn't get why you're doing minus 1 minus.
Yeah, so it is saying 95%. So can this data be 95%, the shaded region? No, right? This shaded region that you see, it cannot be 95%.
Yes.
So the thing is that the Z value always gives you, the Z table always gives you the area for less than. So this 95 that you see is this area. So you can always think that the less than value will be, this is P. Okay, this is P. And this side, so the less than side is P and the greater than side is 1 minus P. Okay, so what is the P value? 0.9525. So what is 1 minus P? 0.0475. Okay, let's move to the next part. Okay, now the thing is that there are different kind of distortion, like whatever we have discussed so far is just a ideal normal distribution. Although the normal distribution will not be ideal always, okay, there are few different kind of distortions which can happen. Okay, so we will try to learn what are the different distortions that we can have now in a normal distribution. First is your like the normal distribution that we have. Normal distribution. Okay. Second is our negatively skewed distribution. Okay, so we will see what is negatively skewed means. And third one is positively skewed distribution. Okay, we'll see what are these three different types. The first one is like I think we already know, right? A normal distribution is nothing which is symmetric around the mean. Right, more or less, I would say something like this. Right. In this case, the mean and median will exactly be the same. Whatever is my mean, the same will be my median. There is no skewness in the data. So the skewness will be 0. Okay. So the second possibility is the data may be a little bit more skewed towards median. Oh, sorry, a little bit more skewed towards the negative side. Like something like this. And on the positive side, it is like this. Okay, so there is a fat tail, we call it a fat tail. There is a fat tail towards the negative side, but it is normally distributed uh, on the positive side. Okay, there's a fat tail towards the negative side. So the mean will be somewhere here. And this will be median. Okay, so in this case, what will happen? Your mean will be less than the median. Why? Because this fat tail, these values which are distributed towards the negative side, they will pull the mean towards itself. Okay, they will pull the mean towards itself. So the mean will become lesser than median. You can just say, I will not call it outliers because these are not few values. There are significant number of the values on this side, on the left hand side. Okay, that's why the mean will be less than the median. And the skewness level, and later we will see how to calculate skewness, but the skewness level will be, the skewness value will be less than 0. The skewness value will be less than 0. And the other possibility is that the data is skewed towards the positive side. So it means that here it is normally distributed, but on the positive side, there is a fat tail. Okay. The positive side, there is a fat tail. In this case, the mean, these values will pull the mean towards itself. So the mean will be somewhere here, greater than the median. Mean will be greater than the median, and the skewness value will be greater than 0. Okay. So let me show you as well. If possible, let's try to see a better image. Skewness. Yes. Mhm. Yeah, more or less like this. Right? If you have a fat tail towards left side, we call it fat tail towards left side, then it is a negatively skewed data. If you have a fat tail towards positive side, we call it positively skewed data. Right? More or less like this.
So
Okay. So what is, yeah, tell me.
in case of no skewness, then it is normal. So mean and median are same, right?
Right. Mean, median, and mode, even mode is also the same. Okay. What is the formula for skewness? Let's see.
Like, what's the mean of skewness?
What is the meaning of skewness?
Hmm.
I will show you. Just 1 minute. So skewness formula is summation xi minus mu cube. Okay, cube divided by sigma cube and divided by n. Okay, do we need to remember this formula? No. Just for your information sake, I have written it. Okay, but we need not to remember this. Although the one thing that we need to remember is that it will be equal to 0 for a normal distribution. If it is greater than 0, then it is positively skewed. If this value is less than 0, then we call it negatively skewed data. Okay, so I try to imagine it in this way, that if this is what my normal distribution is, and then okay, if this is my normal distribution, if your peak, right, the peak that we have, like on top, if your peak moves in the left and right direction, that is called skewness. Like now your normal distribution, it is not normal because it is not symmetric around the mean. So it means that this peak, if you focus just on the peak, you will see that the peak will move towards right hand side in case of positively skewed data. Okay, let me make it a little bit more flat. Okay, and the peak will move towards the right hand side, sorry, left hand side, in case of a left skewed data. Right? So this is more or less, in this case, this is the normal distribution. Right? The middle one. Then this one, you can assume it to be the, is it positive skewed or negatively skewed? What kind of skewness is this?
Positive.
Positive, right? Because more data is distributed on the positive side. Okay? More or less like this. Okay, and then so your peak was supposed to be here, but it moved towards this side. So the peak moved towards this side. Okay, similarly, this one. This is negatively skewed. This distribution. So when the peak is moving in the horizontal direction, when the peak is moving in the horizontal direction, that is called skewness. Okay, there is one more possibility. So this is first of all normal distribution. This is positively skewed. And this is negatively skewed. This is negatively skewed. Okay, this is normal distribution, positively skewed, negatively skewed. This is based on the movement of peak in the horizontal direction. Why emphasizing on that? Because there is another kind of deformation which can happen. The next kind of deformation is okay. The peak can like in the skewness, the peak was moving in the horizontal direction. Sometimes it was moving towards the right, sometimes it was moving towards the left. If it is moving towards the right, the peak is moving towards the right, okay, then it is like the peak moved towards the right, then it is a negative data, negatively skewed data. If moves towards the positive side, then it is if it moves towards the negative side, then it is a positively skewed data. Okay, here the peak has moved from here to here. Okay, the next kind of, I was saying that the deformation can be when the peak moves in the vertical direction. When the peak moves in the vertical direction. So it means that this will remain as it is. It's just that sometimes the peak will be higher than what it should be. The peak will be higher than what it should be. Okay, this is one kind of distortion from the normal distribution. Or the peak will be flatter than what it should be. Okay, peak will be like of the lesser height than what it should be. Okay, let me color code it. First of all, again, is our normal distribution, the blue one that you see. Okay, this is our normal distribution. Okay, now as I was saying, the peak can move either in the up direction or the down direction. If it is moving towards, let's say, the up direction, this one. Here the peak is at a higher level than what it should be.
How do you decide at what the peak should be? Do you have any?
Sorry?
How do you decide what should be the peak? Do you have any?
Yeah, we have a formula for that. Okay, I'll tell you the formula later. So when the peak is, the more than what it should be, okay, it will be called leptokurtic. Leptokurtic. Okay. It's called leptokurtic. Again, no need to remember the formula as such. You should know that there are mainly two types of distortion which is possible from the normal distribution. One is skewness. Okay, whatever we are discussing over here is something skewness. Okay, in case of skewness, the peak moves in the horizontal direction. This is called skewness. And when the peak moves in the vertical direction, that kind of deformation is called kurtosis. This word you can remember if you want. It will be better, but you need not to remember leptokurtic and platykurtic. If you can remember, good. Otherwise, not needed. Okay. So when the peak moves in the vertical direction, that is called kurtosis. If it is what it should be, then it is normal distribution. When it is more than what it should be, it is called leptokurtic. When it is flatter than what it should be. Look at this data. When it is flatter than what it should be, it is called platykurtic. It is called platykurtic. Again, you need not to remember the name, but I'm just saying that mainly these two types of deformation can exist. When the peak is moving in horizontal direction, that is skewness, right? And when the peak moves in the vertical direction, let's say higher than what it should be, lower than what it should be, that is called kurtosis. Okay, the formula for kurtosis is xi minus mu 4 n times sigma 4. This is the formula for kurtosis.
Puneet?
You tell me.
Yeah, sorry. So the red highlighted line is higher one, right?
Right, yes.
And the green highlighted one is a lower kurtosis.
Right, yes.
Okay.
N is the number of data points, right?
N is the number of data points. That's correct. Okay. So tell me.
So he'll explain skewness meaning. Like, what's your meaning for negative and positive skewness? I'm not getting.
So positive skewness means or negative skewness means like in terms of like in general the tail, we call it fat tail, and we don't use the term thin tail, but let's say whenever this is called tail, right? This is a tail. So when the tail is very fat on the positive side, this tail is very fat on the positive side. Okay, this thing, this much area. This is fatter than what it should be. Okay, so that's something we call it positive. It means that what is the meaning of being fatter on this side? It means that there are more number of data points present on the positive side than it should be. Okay, there are more number of data points present on the positive side than it should be. That's why it is called as positively skewed data. In a normal distribution, on both the sides, there will be same percentage of points. Okay, on the positive side also same percentage of points, negative side also same percentage of points. But in case of positively skewed data, there will be more number of points on the positive side than it will be on the negative side. Okay, similarly, on a negatively skewed data, there will be more number of points. Let's say, for example, here, this much. Okay, there will be more number of points on the negative side than it is on the positive side. That's why it is called negatively skewed data. And that's why in case of negatively skewed data, the mean, that is the average, is less than what is the median is. Because these negative values, these high negative values will pull the mean towards itself. Okay, and if you look at in terms of peak, the peak is moving in the horizontal direction. But when the peak moves in the vertical direction, that is called kurtosis. Okay, here the data is symmetric around the mean. It's not like that the data is not symmetric, the data is symmetric. Okay, but the peaks are either higher or flatter than what it should be.
Puneet, in this graph, what is the value of n here?
N is the number of data points. So it will depend upon each distribution. So let's say in a distribution there are 10,000 data points, the n value will be 10,000. If in a distribution there are 1 lakh data points, the value of n will be 1 lakh.
Okay, got it. Thank you.
Okay, how, like, first of all, remembering the formula for skewness and kurtosis is not important. But if you want to, like how I remember it this way. The first formula that I remember is for Z value. I'll show you how these formulas are very similar to each other. Z value is nothing but xi minus mu divided by sigma. Okay. The second formula that I can remember is the standard deviation, sigma or standard deviation, right? Which is nothing but xi minus mu square divided by n. Why there is no sigma here in the division? Because obviously I'm calculating sigma, so I cannot put a sigma in this. And this is how I remember it. Xi minus mu square divided by n. So the same thing, like whatever is inside, more or less the same thing is coming here also. Right? Now if you look at the skewness formula, the skewness formula is the same thing. Xi minus mu is just that now this time cube. Right? So here, if you look at it, the power was 1. The power became 2. The power became 3. Like the power was 1, the power was 1. Okay, here the power became 3 and 3. And let's say similarly, for kurtosis, the formula is same, is just that now it will become 4. I hope you guys are being able to see a pattern, right? So the same formula is there, it's just that the powers are changing. Here it was power 1, then power 2, power 3, power 4. When the power is 1, it is Z value. When the power is 2, it is sigma. When the power is 3, it is skewness. When the power is 4, it is kurtosis. Okay, so if you want, you can remember it in this way. If you don't want to remember it, that is also fine, because these two will not be needed. But this one and this one, these are the two that you should remember.
Here, what is value of n?
N is the number of data points. Everywhere, n is equal to number of data points. Right? If I will give you a data set, the number of data points in that data set will be n. For example, standard deviation also, if you remember, what was the value of n when we derive the formula of standard deviation?
6, I guess.
Yeah, 5. Let's say here, if you remember, what was n? This was n, right? This one. This was n. What was this 5? The number of data points. 1, 2, 3, 4, 5. 5 data points are there, and that's why the value of n was 5. Okay. No, no, I was not saying anything. I was just quiet for some time. Any question? Yeah. Stevie, you are right. It's just that it will be a combination of kurtosis and skewness, and most of the distortion that happens, that is the combination of these two. Okay, so practically it will always be the combination of skewness and kurtosis together. Okay, there is no separate word for it. It's just that we call it simply distortion, and then we just measure the value of skewness and kurtosis, and we say that okay, this is the distortion in the horizontal direction, let's say, and this is the distortion in the vertical direction. Okay, let's start. Okay, now we'll jump on to the next topic, that is covariance. Okay. So we'll first learn covariance, how covariance is calculated, and then we will jump on to correlation. Okay. And we will discuss what is the application of correlation is. So covariance in itself does not have any application. Okay. But correlation has a lot of application. And to learn about correlation, we need to know first covariance. Okay. Let's say we have this kind of a data where on the one axis I have height, other axis I have weight, Okay, and I have different data points. Uh, mhm. Akastha, right? Akastha, let me complete this topic now because we have started this, and then I'll go back to kurtosis and skewness. So let's assume we have this kind of a data. We have height and we have weight, and we have few data points. Now, okay, let me ask you this thing because I have two variables, height and weight. Both are continuous variable. What kind of graph I should create? Should I create a bar chart, line chart, scatter plot? Right? We should create a scatter plot. So let me create a scatter plot first. Let's say this is 1 point. This is another point. In general, as the height increases, weight increases, or the weight increases, most probably the height is also increasing. More or less, this is how maybe the chart will look like. Now, the first thing that we need to do is to calculate average height and average weight. Okay, so I calculated, let me put it here. Okay. Let's say I calculated the average height, and the average height came out to be somewhere here. This is the first step. Calculating average height and average weight. This is my average height. Average height. And the same way, I will calculate average weight. This is my average weight, that is average H and average W. Okay. Now the next thing that I need to do is, okay, for each point, I will try to find the area. Okay. For an example, let's take 1 point. Let's take this point. So I have taken this point and I want to calculate this area. Okay, this area is how much? This much is the area. Right? What is the projection of this point in terms of area on these two average axes, the average of height and average of weight? Now, if the height of this point is h1, and weight of this point is w1. So what is going to be the area of this point? So area will be, I think, we can write it in this format maybe. The area will be height of that point, right, minus the average height. This h bar means average, multiplied by weight of that point minus w1. Okay, height minus h bar, weight minus w bar. Why? See, what is height minus h bar? Is this much. Don't you think that this is, let's say if this is A, this thing is same as A, and if this is B, This thing is same as B. So this multiplication will give me the area, this shaded area. Yes or no?
Yes.
Right? So now let's calculate. Let's calculate this area. So I'm first calculating A. The value of A is H1 minus H bar. As I said, right? H bar is nothing but average. In general, in statistics, whenever we put a bar or something, the meaning of that is average. It's a very standard thing. Similarly, for B, I will calculate W1 minus W bar. Okay, that is the weight of 0.1 multiplied by minus the average weight. Now tell me whether this H1 minus H bar is a positive number or it is a negative number.
Negative.
It is negative. Why?
It's smaller than the average.
Right. Because H1 is smaller than the average. Right. So this one will be a negative number. So it will be less than 0. What about this one? Will it be negative or positive?
This is also negative.
Negative.
This is also negative. So if I will ask you what will be A into B, that is this area will be positive or negative?
Positive.
This area will be positive. Is this one clear to everyone? Like this is the important part. The signs. Is this positive or is it negative? Like why it is positive, why it is negative? It is clear?
Yes.
Yeah. Can you explain me one?
Yeah.
How A into B is positive?
Because the multiplication of two negative numbers is positive. So multiplication of two positive number is positive. Multiplication of two negative number is also positive. Multiplication of a negative number with a positive number, that is negative.
Okay.
Okay. So multiplication of two negative number will give me a positive number. So this area that I see over here, right? Let's call it that this is the positive area. Okay, this is a positive area. Now let's pick some other point. Some other point in some other quadrant maybe. Okay. Let's talk about this one. Here, the same area I have. This green shaded region is the projection of the point on the averages. Right? These are the axes made by the averages. Now, again, the same thing. This one, let's call it, right? Last time we called A as a height and B as width, the same thing. And now, my formula being the same, I will just copy paste this formula. Okay. Just 1 minute. Yes. We will be needing it on the other slides also, so I'll just paste it here. Okay, in this case, the same thing I will do. I will call it, let's say, H2. And this one, I will call it W2. Okay, let me save the file. So now the A which is there, that is H2 minus H bar, right? A is what? H2 minus H bar. And what is B? W2 minus W bar. Okay. Now in this case, we need to see whether A will be positive or negative. So what do I mean by that is, let's say my A will be what? H2 minus H bar. B will be W2 minus W bar. Now tell me whether H2 minus H bar will be a positive number or a negative number.
Positive.
Positive number. And W2 minus W bar?
Positive.
So this area that we are calculating, A into B, this area is positive or negative?
Positive.
Positive, right? So you will observe like all the points that I have in this quadrant that will lead to a positive area. All the points that we have in this quadrant will also give me positive area. You can take example of other points also, and you will realize that all the points in this quadrant is also leading to positive area. Okay. Now let's try to take a point in some other quadrant. So two quadrants we have covered. So here everything is positive. Here every area will be positive. Right? Here every area will be positive. Let's take another point. Let's say a point like this maybe. I have added a point. Same thing. This is assumed to be B. This is assuming to be A. And this point is H3. This point W3. And if I will calculate again the A, which was nothing but H3 minus H bar, and I will calculate B, which is nothing but W3 minus W bar. Okay. Now, A is a positive number or a negative number?
Positive.
Positive, right? Because H3 is bigger than H bar. So this will be a positive number. What is B?
Negative.
Because W3 is less than W bar. So because W3 is a smaller number as compared to W bar, it will be a negative number. So what will be A cross B?
Negative.
Negative number. Any question on this, like whatever we have done in this calculation? Any doubt that you guys have? No? Clear?
Yeah.
So
Right?
what's the meaning of this positive and negative? So A
Yeah.
means what is pointing out here?
For now, like again, just let's learn it for now, and I will
Okay.
show you the application.
Sure.
Okay. Take it like a mathematics that we are going to apply later.
Sure.
Okay. So a few lectures will go like that. And then we'll start seeing the applications. Okay.
Yeah.
So right now, let's say this number, we saw that this was a positive. This was a positive. This one that we see over here. Okay, let me put it in a different color. This number that this point that we have, this is projecting a a negative area. And I'm pretty sure that if you will make more points in this quadrant, those points will also project a negative area, not a positive area. Okay, so this quadrant is projecting positive area. This quadrant is projecting positive area. This quadrant is projecting negative area. Okay, now let's try to see what this quadrant will project, whether it will project a positive area or negative area. Let's see. Let's say I have another point. Yeah. This being again the A. This much being B. Let's call it H4. And let's call it W4. Okay. Now A, which is H4 minus H bar, and B, which is W4 minus W bar. This A, is it a positive or number or a negative number?
Negative.
This is a negative number. And this B, is it a positive or a negative number?
Positive.
Positive number. So the A cross B that we have is going to be negative or positive?
Negative.
It will be negative number, right? So any point which will be in this quadrant, I can tell you, and you can try it with the other points also, but you will see that all the points in this quadrant will project a negative area. Okay, let me now generalize it. Okay, everything which is here, everything which is here in this quadrant okay, anything which is here in this quadrant will project a negative area, the one which is marked in yellow, and here also. Okay, let me actually remove these points also for now. But let's say if once you have calculated the average, any point which will fall into these two quadrants will project a negative area. Okay, this is negative. This any point here also will project a negative area. And anything in the other two quadrants, right, will project a positive area. Like this will also project a positive area. Any point here will project a positive area, and this anything here will also project a positive area. Okay, now remember this and we will jump on to the another part. Now let's just imagine that I have a few points. Okay, I'm just gonna draw a few points and you need to tell me what will be the summation of those areas for those points. Let's say I have 1 point here, I have 1 point here, 1 point here, one here, one here, one here, one here, one here. Let's say I have these multiple points. And each point will be projecting some area, right? You tell me whether it will be, the summation of all the areas associated with these points, will it be positive or will it be negative?
Positive.
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 Right? Because this point is also giving positive area. This point is also giving positive area. Right? If I'll just calculate the area associated with this point, this is positive, 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 positive. Like if I will calculate the area associated with these points, so the total area, let's say summation of all the areas associated with these points will be positive. Similarly, if I have this kind of a data set, if I have this kind of a data set where the points are distributed in this way, then what will happen? This point will have a negative area because they are in this coordinate. So what will be the summation of area?
Positive.
Negative.
Negative, right? Because the points in these two coordinates leads to positive area. The points in these two coordinates leads to negative area. So the summation of all the area, like summation of all the like if there is a series in which all the points are negative, then the summation of all of those points will be negative. What if it is something like this? And there is 1 point here and 1 point here also. So point being is that these all are giving you positive areas. This is giving you negative. This is giving you negative. Okay, highlighted those also. So what will be the summation of area now?
Positive.
Negative or positive?
Positive.
It will be positive, right? Because most of the values are still positive. Even if there were like a few values are negative, because I'm taking an addition, right? It's a summation. If I'm talking about summation of areas, right, and individual areas I'm like taking of each point, then the overall summation will still be positive. Is this point clear or not clear? This is not a multiplication. This is the addition. Clear, not clear? If there are numbers like 5 plus 10 plus 13, if all the numbers are positive, the summation will be positive or negative?
Positive.
Positive. If all the numbers are negative, -7, -3, -9, -14, summation will be positive or negative?
Negative.
Negative. If most of my number are positive, 5 plus 10 plus 13 plus 19, one or two numbers are negative, let's say -2, -3 plus -8 plus 18, and so on. What will be summation, positive or negative?
Positive.
Positive, right? Because most of the values are positive. So in this case, the case that like we have over here, okay, the case that we have over here, most of the values are positive. Even if there are few values which are negative, the overall summation is still going to be positive. Clear? And the other way around as well, if let's say most of my points are in the negative domain, this is negative, this is negative, this is negative, negative, negative. And there are few points, let's say this is positive, this is positive, and rest of the points are negative because these are in this coordinate. What will be my summation of area?
Negative.
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 Right? Now, let me state very obvious. Okay. There is one limitation of, two limitation of any machine learning, all right, the first thing is a machine learning does not have a common sense. Okay. So what do I mean by that? If I will ask you, if height will increase of a person, what will happen to the weight? Most probably. What will be your answer? If my height is increasing, what will happen most probably to the weight?
What will also increase?
Increase.
Weight will also increase, right? But if you will ask a machine learning model, which is not trained or anything, if you will ask, it will say, I have no idea. Okay, why I have no idea? Because I don't understand what is the weight, what is the height. That understanding is not there. So that common sense is not there. That is one thing. Second thing is maybe like sometimes there are few areas of which we also don't have any knowledge. Like if someone will ask me, right? Not everyone is, let's say, for example, have a lot of knowledge of economics, like how stock market and everything works. So if someone would have asked me, let's say a few years back, what will happen to the stock market if the gold price will increase? I have no idea. If the gold price will increase, what will happen to stock market? I have no idea. Right? Now we know that in general, as the stock market, so I have no idea. Then someone showed me a graph. Someone said that, okay, corresponding to different years, when the gold price was this much was the stock market. So let's say I have no idea how the stock market is related to the gold price. But this is the data that someone just showed me. What is the meaning? So you had no idea about how the stock market and gold prices are related, but I showed you this graph. Now, what will be your understanding?
As the gold price increases, stock price is decreasing.
Right. As the gold price increases, the stock market goes down, or the other way around also. If the stock market increases, the gold prices go down, or the stock prices will decrease, the gold prices will go up. Okay. How you were able to conclude that? How we were able to conclude that?
Is the summation gives us a
By
negative.
looking at the
Terms
dots,
of area.
where it is going.
Right. The main thing is that you were able to comment on that by looking at this chart, right? Yes or no? I showed you this chart. You looked at the how the gold and stock prices are changing with each other, right? And by looking at this graph, you saw that most as the gold price is increasing, stock price is going down. How do we conclude that? By looking at this graph. I was able to see the trend and comment on that. But can a machine learning model see something? Like the way you and I are looking at our screen and trying to understand something, can a machine learning model do that? The answer is no. Okay. For a machine learning model, everything is a mathematics. So the thing that you are seeing right now, like for example here, this is an increasing trend. If the weight will increase, the height will also increase. This is what I'm saying. Or let's say variable 1 and variable 2. If this variable 2 is increasing, variable 1 will also increase. If one variable will go down, the other variable will also go down. How we know that? Because I am seeing that chart. But how the machine learning model will know that? Using the mathematics. What my machine learning model will do, it will calculate the areas associated. Like that is mathematics. Calculating area, like calculating average height, calculating average weight is what? Calculating average height and average weight is mathematics. Right? Then calculating this area, the area that you see over here. What is that? That is also mathematics. Right? So now the trend that you were able to see, like when I had height and weight, just by looking at this chart, I can tell you it is a positive trend. It is an increasing trend. If weight will increase, height will increase. If height will increase, the weight will increase. Then why we are doing all of this? What is the point? The point being is I want to develop a language, right? Some mathematical criteria based on which my model, my machine can also see what I'm seeing. You saw this and you said that if weight will increase, the height will also increase. But machine learning model cannot see. So I gave him a language. I said that calculate all the points, like calculate the areas associated with all the points. If the areas are positive, it means that although I cannot see the graph, but I know that it will be something like this. It will be an increasing trend. Okay. Similarly, if I know that the summation of area is negative, it will be a decreasing trend. And this is not for you. This is not like you will say that I can see it myself. It is a decreasing trend. Why to calculate this area? I can see it is a positive trend. Why to calculate this area? Right? Because it is not for you. It is for the machine learning model. So that the machine learning model cannot see. So machine learning model will calculate the area and it will say, okay, because this mathematical value is coming positive, it means that if I will increase one variable, the other variable will also increase. If I will decrease that variable, the other variable will also decrease. Then when the area is coming negative, my machine learning model by default knows if one variable will increase, the other variable will go down. If one variable will decrease, the other variable will go up. Right? Which happens, let's say, for example, in the case of stock market and gold. Right? So it is not for you. It is for the machine learning model. Now you will be like, if I can do it myself, why do I need the help of machine learning model? You need the help of machine learning model because you can do it for one combination. You can do it for two combination. You can do it for 20 combination. But if I will ask you to do it for 10,000 combination, will you go through the 10,000 charts one by one and mark that this is a positive trend and this is a negative trend? No, right? If I want to do it for 10,000 different charts, I can just teach this technique to the machine learning model and it will be able to tell you what is the relationship between every two variables, whether these two variables are positively related or whether these two variables are negatively related. And how the machine learning model is doing it, it is not seeing each and every chart. It is just calculating what is going to be the area. Is it the area going to be positive or negative? If the area is going to be positive, it is an increasing trend. If the area is going to be negative, it is a negative trend. Okay. So what will happen in this kind of a scenario? My few of my data points are negative. Few of my data points are positive. What will happen in this case?
It will take the summation of all and then
0.
Means if there is a more positive, then number, then it will be positive output.
Right.
Otherwise, it will be negative.
Nice, right? But approximately, you're right. You're not wrong. Approximately, the things will cancel out each other. It will be close to 0. It can be 0.1. It can be 0.2. Right? It can be minus 0.1. But it will be more close to 0, especially as compared to what it was here. Right? Here, there was no point cancelling out this positive value. There were like very, very few points. But here, there are a lot of points which will cancel out the positive value and vice versa as well. A lot of positive points will cancel out the negative value. So it is 0. But see how much useful it is. Remove this. Let's forget about this stock and gold. Let's give them name variable 1 and variable 2. Tell me what is the relationship between variable 1 and variable 2?
Unrelated.
They are
don't show
unrelated. Right. I cannot say that if the variable 1 increases, then the variable 2 increases, or if the variable 1 will decrease, variable 2 will decrease. I cannot make any comment. Why? Because variable 1 and variable 2 are not related to each other. For example, my income and your expenses, right? Let's say income of mine and your expenses will not be related to each other. If my income will increase, your expenses will not go up. Or it's not like if my income will decrease, your expenses will go down, right? Those two variables are totally independent of each other. My income and my expenses are related. If my income will go up, most probably my expenses will also go up. If my income will go down, my expenses will also go down. But if I will make a graph between my income and your expenses, it will look something like this. No relation. Okay, so it means that it can identify all kind of trends. It can identify this as well when it is a positive trend. It can identify this as well when it is a negative trend, and it can identify this as well when there is no trend. When it is an increasing trend, it is a positive area. When it is a decreasing trend, it is a negative area. And when it is a zero area, it means that there is no trend in the uh, between the two variables. Okay, again, remember this thing is only valid, right? We are doing it because we want machine learning model to take this call whether this relationship was a positive, negative, or no relation. If you need to do it yourself, obviously you will be able to just look at the chart and tell whether it is a positive relationship, negative relationship, or no relationship, right? But we do machine learning because we want to scale things. We don't want to go through each and every variable and do it because that is time consuming. It is, you may make a mistake also, right? So we want to have some mathematical way in which my machine learning model will tell you that these are the variables which are related with each other. These are the variables which are not related with each other. Okay, any question? Okay, now from this concept, this is called covariance. The thing that we have just learned, the area calculation, summing it up, that is called covariance. Okay, the standardized version of it is called correlation. Okay, that's something that we will learn tomorrow, right? But correlation is something which is very extensively used, not even in stats. Okay, but even in general, let's say the people who don't even use stats or not data scientists, they also extensively use correlation. Okay, I hope you guys have heard these terms, like these two things are not correlated with each other. You are trying to make a correlation where it doesn't exist. Like I've seen a lot of business people like talking in this language. Correlation means whether the two variables are related to each other or not.
So it will help us like find the trend between like variables. Like
Yeah,
is it
between two
like
variables, right? Exactly.
Here the covariance and correlationship are same.
Covariance and correlation are same. How they are, there's slight difference between the two. I will tell you why, what the difference is. Correlation is nothing but the standardized version of covariance. Why there was a need for correlation is something that I will explain to you tomorrow. Okay, why can't we just simply use covariance? We will see and we will discuss tomorrow. But anything apart from that, any other question? Okay, in that case, that's all for today. And I'll see you guys tomorrow, right? All the topics that we are covering, right? Believe me, those are very important topics. So please do attend the classes. Try to join on time. If in case because some reason you have missed it, please try to revise it. Because all this concept will build upon this, right? As I was telling you, it's more like we are learning the alphabet right now, ABCD, right? Slowly and slowly we'll start making words, and then from those words we'll start making sentences, right? So if you directly come to a class where we are learning how to make sentences, right? So if you have not attended the class of alphabets and words, it will be difficult to understand. Okay, so do attend the classes. We will try to keep it as interesting as possible. I hope you guys are enjoying it so far. And I will see you guys tomorrow.
I have one query.
Mm-hmm. Yeah,
Just wanted to know, do we have any formula for covariance?
yeah, we will discuss. Yes.
Okay.
Okay, tomorrow we will discuss. We'll first see the formula of covariance and then we'll see the formula of correlation and how they are different from each other.
Okay.
Yeah, you were asking something.
Puneet, can you please share the Google Drive link for this
Share what? Sorry.
Google Drive link for
Google
this
Drive
PPT?
link. Okay, just 1 minute. Just stay on the call. I'll share it. Yeah, I've shared it in the chat. Okay, thank you guys. We'll see you tomorrow. Bye-bye.
Thank you.
Puneet, I have a doubt.
Bye.
Yeah.
Thank you.
Like you divided the total graph axis into
Mhm.
the 4 portions,
Right.
Yeah. How that machine and machine understands that it divide into the 4 portions. Like in the last examples, you not shown the 4 portions and you given the values which does not have any trend.
Right. So here the machine learning model is actually going to first create these lines. Whether you see it or not, the machine learning model is going to create these lines. How it will create this line? Average of variable 2 will be this line. The machine learning model will create this. Without it, it cannot calculate. It will calculate average of V1 and then it will calculate all the areas. Area associated with this, area associated with this, this, all the area associated with all the points will calculate, will take a summation of it. Then only it will be able to tell you whether there was any relationship or not a relationship between these two variables. Okay, but machine learning being machine learning, it will be very fast, obviously. Okay,
Like
cool.
the thing what we are doing is done by the machine by itself.
Yeah, right. Everything that we will do in this throughout this course, believe me, it will be just one line of Python code. Whatever we will do throughout. Although we will spend a lot of time doing things manually as well, like using hand, because that helps us in improving our understanding. For example, calculating the Z value, then probability and all of that. There is a one line formula for that, even in Excel, even in Python, right? But why we are doing it by hand, why we are going to a table and then checking all of those values? Because that's how the things stick to you. That's how your understanding improves. So we'll do a lot of things by hand, although it is like when you will be implementing it in Python, it will be very straightforward. Okay.
Yeah, thank you.
Thank you guys. Bye-bye.